The video that we're about to watch is for the Chapter 7 test review. It's a portion of the problems, and so we're going to look at the evaluating the logs. Now in this case, on the first page of the test, you usually have the non-graphing calculator part, or the part where you don't get a calculator. And so in order to do this, like for number 7, I need to figure out what exponent will give me 2 to the what will give me 1 over 32. I know 2 to the 5th equals 32, so if I try a negative exponent, that will flip the fraction. So I try 2 to the negative 5, which actually does give me 1 over 32. The answer I'm looking for is the exponent. So you need to, it's very important that you give me the exponent. If you write it in a different way, I can't tell that you understand the actual problem or what the answer is supposed to be. So here, right here, the answer to these problems when it says evaluate is just the exponent. In this case, it's negative 5. For number 8, I'm going to do the natural log of e to the 3rd. There's a trick or a rule that we were talking about earlier in the chapter that said that if the bases were the same and you have an exponent that's inside of a log, say this exponent right here is inside of this log, if the bases are the same, then the answer will be this number here. So in this case, the answer is 3. Okay, so for all of these, I'm really using the trick 2 cubed equals 8, or 2 to the 3rd equals 8, and log base 2 of 8 equals 3. I'm always thinking that because logs are all about changing from an exponential to a log or log to an exponential. Remember, it's just the format of how we're writing this. So at this point, I'm doing it again. I'm saying 12 to the what power will give me 1. And always remember that anything to the 0 is 1. So in other words, the answers for these are always going to be 0. Okay. Here's another one where we're actually using the rule that said if the bases are the same, then the answer is going to be this number right here, the 3x. Okay, notice that this is a log inside of an exponent. So I'm looking, this is the base of this exponent, and this is the base of the log. So you want to look for 2 bases that are the same. Okay, so for number 11, we have e to the ln 7. Again, I'm looking for, I have a log that's inside of an exponent. So I'm going to just write it out so that you can see it. It's e to the log base e of 7. The e's are the same, so the answer has to be 7. Okay, now this is the last one where we're evaluating without a calculator. So log base 5, 3,125. If you have to do this on the test, then by all means do it. It's not going to hurt anything. I know that I'm looking for the exponent. 5 to what power, 5 to what will give me 3,125. So I just start multiplying 5 times 5 times 5 times 5 times 5. That'll give me 3,125. So I counted how many 5s did I have? 5 of them. So the answer is 5. All right, we're going to skip from number 12 all the way over to number 25 in the test review. The reason why is because now we're evaluating the log, same thing that we were doing before, but now we get to use the calculator because there's no way to figure out what the exponent's going to be. This is e, because natural log means log e, right? So this is e to what power? To what power gives me 16. The only way that I can do this is by using the calculator. And if I use the natural log button, which is ln, right underneath the log button, if I just do ln and then type in 16 and press enter, I will get my answer. It is very important that you remember to round to 3 decimal places, which in your packet, it'll say round to the 1,000th. Okay? All right, so Let's look at number 26. Okay, log base 2 of 9 equals what? I have to put in the calculator. Do you remember that there is a trick in the calculator where you do log 9 divided by log 2? The reason is because the calculator button, the log button, only has a log base 10. If it only does a log base 10, there's no way I can put log base 2 of 9 in the calculator unless you have a better calculator. So what I'm going to do is I'm going to use the rule called change of base. And in the test, it will say change of base. That is simply just the trick of putting in a log base 10 of 9 divided by a log base 10 of 2. Will you please remember that in your calculator you have to put the parentheses or it won't work. Okay, if you do log base 10 of 9 divided by log base 10 of 2, then you should get 3.17. I did round to 3 decimal places, but the problem was that it rounded up for me, and that's what I got. Okay, number 27 is log base 7 of 25, which means I'm going to use the change of base rule again. Log 25 divided by log 7. Make sure you put in your parentheses, and you will get 1.654. Okay, so since we're here, we only have three different problems that we need to work. Let's work them now. So we're going to do number 28. This is finding the inverse. Please remember the inverse of a log is an exponential. The inverse of an exponential is a log. They reflect each other on the graph. Okay, so therefore I change the x's and the y's. Okay, here we go. We have changed the y to x and we've changed the x to a y. I've written out the exact same equation, just switching those variables. If it's a log, I'm expecting to see an exponential. These are actually really easy for me to grade because it's very important to watch. If you know you started with a log and if you don't have an exponential for your answer, then it's wrong. If I look at it and say, oh, the problem was a log and the student gave me a log, then I know something happened. So I watch for, hey, did the student give me the opposite of what I'm looking for? If they did, I'm like, great, they understand what's going on. So here we go. We're going to do, we're going to convert. So first of all, we switch the x's and the y's, and now we're going to convert. Okay, so I'm going to start with my base number, which is 7, and it's 7 to the x equals y. Watch out for your exponent. It should be 7 to the x, not 7 to the y. Okay, all right, let's do 29. Now 29 is the same type of thing. It's a log, so I'm expecting to see an exponential equation when I inverse it. So I'm going to switch the y to an x, and the x is going to become a y. My problem is that I have this extra piece right here. Okay, I'm expecting to make it an exponent, but I can't convert it without moving that extra piece over. Okay, and on top of that, now this x minus 1 has to stay as one thing, as one piece. So I'm going to convert 5 to the x minus 1 equals y. And that is going to be my answer. Okay. This is the last inverse problem. This problem is an exponential. So my answer, I expect to see a log equation. I'm going to switch the x's and the y's. Remember that you switch and you convert. Here's the problem. A lot of people will switch, they'll think they're done, or they won't know what to do after this. But I'm looking for all the pieces to make the log. After I've switched, now I'm doing the convert right here, which is log base 2 of x equals y minus 1. My problem is that now I have an extra 1 on the side. So I'm going to go ahead and move the 1 over, which is add 1. Okay? Please remember that this x, this log 2x, was all by itself. When you add the 1, it's really on the outside, which is like graphing the log and shifting it up 1, okay? If it had been with it at the time that you converted, then fine, it would have been with the log. But since you moved it after you converted it, it just sits on the outside, okay? All right, so that is the inversing problems for the test review. There will be a few problems on the test where you have to inverse, and let me just say it one more time. It's very important that you switch the x's and the y's, but you're not done. Then you have to convert. If you're an exponent, you convert it to a log. If the problem is a log, you convert it to an exponent. All right? Okay, thanks for watching.